Hello everybody, my name is Calvin with student ID number of 22055311140. I am currently studying mechanical engineering in Udayana University. In this video, I am going to present my presentation about polymers. This presentation is made for the assignment for Engineering Materials Knowledge, subject lectured by Professor Dr. Tjokorda Tirta Nindhia, STMT. All the materials that were used in this presentation is taken directly from this book entitled Science of Engineering Materials, Volume 2 by Menas Chanda. The content that will be discussed in this presentation are molecular weight of polymers, definition of resin and plastic, polymerization process, and structural shape of polymer molecules. First is molecular weight of polymers. In pure low molecular weight compounds, such as sucrose, all the molecules are of the same size and so have identical molecular weight, or M. Such compounds are said to be monodisperse. In contrast, most polymers are polydisperse, that is, they consist of molecules of a range of sizes and molecular weights. Hence, it is necessary to calculate an average degree of polymerization, symbolized by dP, or an average molecular weight, M. The molecular weights commonly used in the characterization of a polydisperse polymer are the number average, weight average, and viscosity average molecular weights. Consider a sample of polydisperse polymer of total weight W, in which N is total number of moles, and I is total number of moles of species I. The small n is mole fraction, the capital Wi is weight of species I, and the small w is weight fraction. The capital Mi is molecular weight of species I. First is we will calculate number average molecular weight. By the definition of molecular weight as weight of sample per mole, thus Mn, or number average molecular weight, equals W over N equals sigma Ni times Mi over N, and equals sigma small ni times Mi. And the second equation of Mn is sigma Wi over sigma Wi over Mi, and so on until we get this equation. And by dividing Mn by the mere weight Mo, or M0, a number average degree of polymerization dPn is obtained by dividing Mn over M0, where Xi is the degree of polymerization of species I. Mn is obtained by N-group analysis of or measurement of a colligative property such as elevation of boiling point, depression of freezing point, or osmotic pressure. The equation before indicated that in the computation of Mn, molecular weight of each species is weighed by the mole fraction of that species. Similarly, in the computation of weight average molecular weight, the molecular weight of each species is weighed by the weight fraction of that species, with Mw equals sigma the total of small wi times Mi equals this, and so on until this. The weight average degree of polymerization dPw is obtained by dividing Mw by the mere weight. Nw can be determined by measuring light scattering of dilute polymer solutions. Mw, or weight average molecular weight, is always higher than number average molecular weight. The viscosity average molecular weight is defined by the equation mv equals sigma wi fraction weight fraction of species I times mole times mole weight of species I to the power of a to the power of 1 over a. For alpha equals 1, this is alpha. For alpha equals 1, mv equals mw, and for alpha equals alpha negative 1, mv equals mn. mv, or viscosity average molecular weight, falls in between mw and mn, and for many polymers it is 10 to 20% below mw. mv is calculated from intrinsic viscosity, symbolized by eta, by empirical relation, with eta equals k times mv to the power of alpha, where k and alpha are constants. Eta is derived from viscosity measurements by extrapolation to zero concentration. Next is polydispersity index. The ratio of weight average molecular weight to number average molecular weight is called the dispersion or polydispersity index, or I. It is a measure of the width of molecular weight distribution curve, like seen in this figure, and is used as such for characterization purposes. Normally, I is between 1.5 and 2.5, but may range up to 15 or even greater. The higher the value of the I, the greater is the spread of molecular weight distribution of the polymer. For monodisperse system, in other words, pure chemicals, I is equal 1. Next, we'll discuss about the definition of resin and plastic. Both the terms resin and plastic are in common use, but there are no explicit definitions for them. The term resin originally referred to for vegetable-derived organic products of relatively high molecular weight, but the term is now used much more broadly and rather loosely to include the man-made polymeric substances used in a variety of applications such as plastics, textiles, and paints. It is often used interchangeably with the term plastic. Plastic is an adjective defining a material that is capable of being molded or shaped, with or without the application of heat. Strictly speaking, a plastic therefore a permanently deformable and moldable material, with plasticos meaning fit for molding. The process of polymerization are divided into two groups known as step polymerization and chain polymerization. Step polymerization occurs by stepwise reaction between functional groups of reactants. The reaction leads successfully from monomer to dimer to trimer, tetramer, pentamer, and so on until finally a polymer molecule with large dp degree of polymerization is formed. It should be noted, however, that reactions occur at random between the intermediates and the monomer, as well as among the intermediates themselves. Chain polymerization proceeds by a mechanism distinctly different from step polymerization. Chain polymerization involves three processes, namely chain initiation, chain propagation, and chain termination, and sometimes a fourth process, change transfer, may also be involved. It may be regarded as a combination of chain termination and chain initiation. Chain initiation occurs by an attack on the monomer molecule by a free radical, a cation or an anion. Accordingly, the chain polymerization processes are called free radical polymerization, cationic polymerization, or anionic polymerization. A free radical is a reactive substance having an unpaired electron and is usually formed by the decomposition of a relatively unstable electron and is usually formed by the decomposition of a relatively unstable material called a catalyst or initiator. The next step is copolymerization. All the polymers we have considered so far contain only one type of repeating unit or mer in the chain. Polymers can also be synthesized by the aforesaid process with more than one type or mer in the chain. Such a polymer are called copolymers and are produced by polymerizing a mixture of monomers, or so-called copolymerization, or by other special methods. Copolymers can be of different types depending on the monomers used and the specific method of synthesis that is employed. The copolymer, which has a relatively random distribution of the different mers in the structure, is referred to as random copolymer. The non-random copolymer structures are referred to as alternating, block, and graph copolymer structures like seen in the figure. A is the random structure mentioned before, B is the alternating structure, and C is the block structure, and D is graph copolymer where there is branches in the chain. Polymers can be classified on the basis of structural shape of polymer molecules is linear, branched, or cross-linked. Schematic representation of these polymers are given in this figure. Linear polymers are those which the repeating units are linked together in continuous length, which on A figure. When there occur branches protruding from the main polymer chain at irregular intervals, the polymer is termed as branch polymer. There may be long or short branches forming a comb-like structure like B figure, or there may be branches like C figure forming a dendrite-like structure. D and E are cross-linked polymer structures where the branches are of one chain is linked to another chain. Thank you for listening to my presentation. If there is mistake in my presentation, feel free to correct me in the comment section. Bye.